In this video, we're going to talk about how to make comparisons using z-scores. I have an example here, so let's get started by reading through the example. Mary and Sarah are competitive siblings. Mary is in the 8th grade and Sarah is in the 6th. So Mary must be Sarah's big sister. Mary got an 84% on our last math test. Okay, I'm going to go ahead and write that down as x equals 84. Okay, so x is going to represent Mary's math score. And Sarah got a 95%. So I'm going to write that down as y equals 95. Okay, so over here this is Mary, and over here this is Sarah. Alright, so we're going to assume that the math test scores are normally distributed, and in the 8th grade, which is Mary's grade, the average score is 70% and the standard deviation is 7. So the random variable x, which represents all possible scores for 8th graders, is normally distributed with mean 70, standard deviation 7. Okay, so this is mean, or mu, and 7 is the standard deviation, or sigma. Okay, in the 6th grade, the average score is 90% with standard deviation 5. Okay, so capital Y, random variable for the scores for 6th graders, is normally distributed with a mean of 90 and standard deviation 5. So this is mu and this is sigma. Okay, so who scored best compared to the others in their grade level? Right? At first glance, you might say, oh, well, golly, Sarah got 95% and Mary only got an 84%. So Sarah clearly did better. But that's not really fair because Mary is in a more difficult grade, and as you can see, on average, her peers didn't perform as well as Sarah's peers, who on average scored 90. Okay, so a more fair way to do this comparison between Mary and Sarah would be to first, let's calculate their z-scores. Let's calculate how they did compared to their grade level, to others in their grade level. So starting with Mary, z is x minus mu divided by sigma. X here is Mary's score of 84. Mu is 70, the average score. Sigma, our standard deviation, is 7. Okay, 84 minus 70 is 14, divided by 7, which is 2. Right? So if you were to draw out this distribution, in the center we have 70. Mary's score is up here at 84. And it looks like, so Mary, since the z-score is 2, she scored 2 standard deviations above the average. All right, so now let's go and look at how Sarah did compared to her peers. So z equals, instead of x, we'll write y minus mu divided by sigma. 95, mu here was 90 for Sarah's grade, and sigma was 5. Okay, so this is 5 over 5, which is 1. Okay, so if I were to draw this out, right, in the center I have 90. Mean for Sarah's grade is 90. She scored a 95, right, which we've just calculated is only 1 standard deviation above the average, right, because the z-score was 1. So who did better compared to the others in their grade level? Mary. Mary did better. Mary did better comparatively because she scored 2 standard deviations above the mean, but Sarah only scored 1 standard deviation above her mean.